Here's the code that's running in the background of this web application. Now, as I mentioned earlier, this is an ASP.NET MVC web application. So this is the controller that's called when there's a GET request made to this path, cars by cylinders. Now this path takes one parameter, and it's this one, the cylinders parameter. And what happens in the code is that this cylinders parameter is taken down a couple of lines below this, on line 15, and you can see it already highlighted in a string containing SQL syntax. So this query is just being manually built up and the data concatenated with the query. So in the last module, I talked about the differences between query and data. We looked at this when we looked at updating colors, and we had purple and violet. That was the data, and the update statement was the query. And what's happening here is that once you get past line 15, they're all mixed up together. It's just concatenated. So the application, and certainly the database server, doesn't know where the query ends and where the untrusted user data begins. There's absolutely no validation that the cylinders parameter here actually contains valid cylinders, and the application is just blindly taking that parameter, throwing it into the statement, and executing it against the database server. Now later on in the course, we'll look at how to do this securely using SQL command parameters. And that's going to fix this problem right up. But one other thing that's missing here is input sanitization. So there is nothing here that talks about what is allowed in this cylinders string. And as we now know, we can pass a lot of stuff into this parameter which we really shouldn't be able to. So a really key thing with SQL injection is validating that untrusted user data. So really here we should be saying, before we do anything, does this data conform to a known good pattern? And what we really want developers doing is actually whitelisting those patterns. Now think about what should be passed through here in cylinders. We've seen an engine configuration and a number. So in the case of our application so far, you could almost just whitelist it. You could have V6s, V8s, V10s or V12s. Anything else shouldn't be allowed. You could be a little bit more generic and regex it. There must be a single letter followed by a 1 or a 2-digit number. That would cover everything we have in the system at present. You might even get a little bit trickier and say, well, what happens if we end up with a flat 6? We start adding Porsche 911s. Well, in that case, we might want to whitelist cylinders just to alphanumeric and spaces. So that would be a very constrained list of allowable characters. If you only allowed letters, numbers, and spaces, there is no way you could mount any of those attacks that we've looked at to date. Quotes would be disallowed, semicolons disallowed, equals sign disallowed. All of these attacks would fail. The trick for you now, as an ethical hacker, is to understand what sorts of characters might be useful to test against the application to see if there is any input sanitization happening. So let's move on and have a look at exactly how input sanitization works and what some of the characters are that you should be looking out for.